Hey, it's Jen for Tested, here today to talk about something that I do in a lot of videos that I've done for Tested, and I wanted to take kind of all these little bits and pieces and culminate them together into one kind of nugget of information, and that thing is prototyping. So as you can see, it's a huge part of my process in design and making things, and there's so much involved in it. There's tons of different materials and kind of design philosophy, and I have a very specific process in the way that I take something from idea to sketch to prototype to finished object. And I kind of wanted to just talk through that process and give an overarching explanation of my design thinking, my thought process of as I go through this, what does that look like for me, because it's different for everyone. So to start off, my beginning step before I even touch any materials is to take out my sketchbook. And I usually start off just by drawing the object that I am trying to either make or that I'm trying to make something for. So in this case, I was working on a spotlight and I wanted to make some barn doors for this object. And so the first thing I do is just draw out the shapes to get an idea of the structure and what I'm working with. And in the process of doing that, I'm sort of getting to know all of the geometry of that object. So in the case of the light, I figured out that there's a base stand, there's this sort of convex lens, then there's also these rings around the edge that have different dimensions. Once I have a drawing, that also gives me a space to start putting in measurements. Whenever I'm prototyping, most often, the dimensions are somewhat important because I want to be able to translate that cardboard or foam core mock-up into an actual object. So the drawing gives me a place to start marking those measurements down, and I'll sometimes draw from a couple of different perspectives. So I'll do like an isometric view and an orthographic view so that I can see it from all different sides, just to capture the information about each different component that I need to see for the design. Once I have my drawing, and they vary in detail. Something might be as quick as like a little napkin sketch, or it might be super detailed if I'm getting more into the idea of like concept art. From there, I will do one of two things. Sometimes I will take the drawing and physically translate it onto a piece of material. Other times I'll take that and just use it as sort of a reference and a guide. And that is sort of the next step, taking the sketches from the 2D world into the three-dimensional space. So for this part of the process, there's so many different choices for materials you can use to prototype. I use pretty analog stuff, just cardboard, cardstock, foam core, for a couple of reasons. So it's easily available, obviously, it's inexpensive, but for me it's also about the sort of efficiency of using these objects. You can 3D print a prototype, you can make a prototype out of clay, but using sort of paper and cardboard makes the process much quicker for me. I'm a lot more fluent, and I can take the ideas from my head and translate them quicker into the three-dimensional space. So I'll usually use a couple different things. Cardstock, just a relatively heavyweight paper. You can use this for small things, such as this, which are detailed and kind of intricate. I also find this is good if you are planning to take your design and then make a pattern out of it, because you can cut this, you can draw on it easily, and it translates very well into digital form to scan. We'll talk more about that later. Then obviously cardboard, this is my number one. I save tons of recycling boxes that would otherwise, be trashed. But if I've got a nice big flat piece of cardboard, I'm usually going to break it down and save it because I'll use it eventually to make one of my prototypes. There's tons of different kinds of cardboard. You'll find this sort of single ply thickness is pretty common, but there's also much heavier duty stuff. This generally works for what I need. Sometimes I'll layer it. And we'll talk about some techniques for using cardboard. The last thing would be foam core, and I just have a couple of little pieces here to show. Probably familiar with this. It's got a foam inner layer, paper, front and back, And this is easy to cut. It's also really great for joining because it has a pretty uniform thickness. So it's easy to glue pieces to each other and because there's a nice flat surface area. Before I start building anything from the sketchbook, I want to figure out exactly what I'm trying to get out of the prototype. So there's different design constraints that the prototype will help me solve, whether it's the geometry, whether it's the scale, whether it's the relation of the object to people or to other things in a space. And I'm trying to think of all of those different relationships when I'm trying to decide what material, what level of detail, what scale to make the prototype in. And what I mean by that is you can build something that is just like a three-dimensional sketch, essentially. So something like this little cart here. This is sort of, scale was irrelevant. The only thing I was concerned about was getting a rough idea to visualize something and to show it to other people at the makerspace of what I was imagining. So this is just like a really quick, very rough idea of what this object is going to be. The finished product ended up looking somewhat similar to this, but in this case, scale was not super important. For something like this little spotlight, this was an add-on to an existing object. So in this case, scale was super important because it had to fit onto an item that already existed, with design constraints being the dimensions of the thing I already have. So for that, I used foam core, and I also used some cardstock to kind of make all the different versions. So I started off with this one in chipboard, and I quickly realized this is what prototyping helps with. I quickly realized that these barn doors, because of the way I cut the angles, they don't quite fold in and prevent the light spill, which is what they're intended to do. This sent me back to the drawing board, and I figured out that in order to get the fins to sort of close in, the side ones needed to taper inwards. And having a prototype allowed me to sort of discover that flaw in the geometry that I designed. And that is the exact pattern that I used to create the final fins. So in this case, I needed the scale to be exact, and I wanted to be able to pattern off of my prototype to create the actual object. So this one had to be a lot more specific. Another example of an application for this is when you're making something that you want to figure out how it fits into a space, like a room. So you can do a mini mock-up of a space like a workshop. I made a foam core model of Adam's storage space so that we could organize and figure out the floor plan. I've also done things like this, which are at 1:1 scale. And the importance of that is I want to be able to relate to the object in real space. So I can make a digital version of this, I can do a rendering and see how it looks next to the scale of a human, but it's really hard to grasp exactly how it's going to feel to interact with this object in the real world until it's in front of you, until you can hold it in your hands or you can stand next to it and you can get that relationship. So in this case, we were 3D printing a skeleton, and the constraints were it needed to fit on the 3D printer, but also we wanted to know how it would feel to the viewer. So the idea was that when you're standing up next to it, I'm actually about the same height sitting on this stool as I am standing, but you wanted to be able to basically look into the eyes of this creature. And so I played around with the height of this sculpture platform, played around with the height and the thickness of these dowels here. All of these things informed my design decision. So initially I had thought I was going to use a much narrower dowel to display this, but when I made the prototype I realized, oh, this actually needs something with a little bit more weight to stand up to the one. From an engineering standpoint, it needs more support, but also from a visual standpoint, it needed a little bit more thickness to match the sort of heftiness of this giant skull. So that's another example of a application for this. Another thing that I do a lot is with laser cutting. So I will kind of go through a whole stage process of concepting in cardboard and foam core, starting to make laser cut prototypes, and then I'll keep iterating on those. In this case, it's a very specific dimension that I'm trying to get. So oftentimes the cardboard is a direct analog for the final object that I'm making. So I'll show you a couple examples of this. So this is the first version to start. This was just me solving for the shape, kind of had an idea of scale, but you can see that this version is much smaller than what I ended up with. So as I go through the process, I'll translate that into the material that I'll be using. And then I start to design, Then I start to design the actual shape. So I'll take my original versions, make any edits to them. I am a big fan of writing right on the prototype. It's basically a three-dimensional sketch, so I make all of my notations right on it, and I'll make the edits. So you'll see I put little arrows in places, I make adjustments to things, and then I'll take that to the design software and edit based on what I've seen in physical space. So you can see a couple different versions here, and then I was able to take those patterns from the cardboard and get a pretty accurate copy made in plywood and acrylic. So this is the final version, and you can see the kind of evolution from start to finish. The next thing that I want to go over are some techniques for working with these materials. It might seem super straightforward. It's cardboard, it's foam core, it's easy to cut, but there are some specific ways that I sort of work with these for prototyping. So cardboard, first and foremost, has a grain to it. The direction of the corrugation will dictate how the material wants to bend and fold. So it's very easy to bend it along the corrugation, not as easy to bend it across the grain. You can. So the main things that I'll be doing is cutting and scoring. So I've got a cutting mat, nice straight edge, and I'm going to put a fresh blade in my knife here. So for this, I'll use either an X-Acto or a utility knife like this Olfa knife here. And I'm going to get a fresh blade on this one too. So for cardboard, you can obviously cut along the grain and across the grain, but more often than cutting, I'll actually score it. And I'll just go very lightly up against the straight edge, not putting full pressure all the way through the material. That allows me to bend along the seam. This works along the grain, but it has an even better effect if you go against the grain. So typically when I'm scoring, I try to work against the grain of the cardboard. I'm basically just cutting through that top layer. I don't want to go too deep through the level of corrugation. So then I can sort of crack that along the seam there. And you can use this to create right angles. You can use it to make flanges. This is also a great place to put glue to join two parts together. We'll talk about joinery in a minute. Another thing to consider is the curvature. So obviously when you're doing something like a curve, you want to work with the grain. And one thing to note about corrugated cardboard, it doesn't have a ton of strength, but if you roll it into a tube, this is incredibly strong. You could probably set up a few of these and almost stand on top of it because it is very, very rigid. So that's something that you can use to your advantage when you're assembling pieces if you need something to be super structural. Another thing that you can do is to layer pieces on top of each other. and glue them together, but we'll talk more about joinery in a minute. Next up is foam core. This comes in a ton of different thicknesses. You can get different colors now. I usually work with just black and white for prototyping because it's easy to mark on them. White, obviously, it's very easy to draw on with Sharpie or sketch stuff out in pen or marker. Again, fresh blade, nice straight edge. And when you're cutting foam core, you want to do this on multiple passes. So we're not going to go all the way through at full pressure on the first pass. And usually takes about 3 passes to get all the way through. Sometimes it doesn't fully, there we go. And we've got a nice smooth edge. You can obviously also score foam core. So same thing here, just light pressure. I'm only cutting through that top layer of paper and I'll get a nice sharp corner there. You can use this to great effect if you want to build boxes. So I would do score lines in perpendicular directions. And then actually cut out that little corner overlap. And now I've got a full corner. Another thing that you can do, this is slightly more advanced, but can be done, is to cut out like a wedge, and that will allow you to get kind of smoother curves. I'm gonna get a little bit more of the blade out here. And this is pretty tricky to do, but I'll just try to show you as best I can. When I say to cut a wedge, I'm going in on kind of like a 45-degree angle. So I'm going to, so it's going to carve out just like a little wedge from the side of the core of the foam. And you can see that this is it's not a full score. I'm not going through that backing paper, but if I were to do a bunch of these little wedges, I can then get a nice rounded curve. And depending on how steep your angle is when you're cutting the wedge out, you can get more drastic curves. You can also change the spacing between the wedge marks, and that will also change the shape of the curvature. So one of the easiest ways to join cardboard is with either tape or hot glue. And you can join it in a couple ways. Obviously you can stick 2 pieces together. This is great if you need a little bit of extra sort of directional strength. This is best if you alternate the grain direction. So on this piece, I've got the grain going long ways like this. And on this piece, I've got the grain going crossways like this. If I were to stack these 2 pieces together and glue them, I've got a much stronger piece of material because the grain is opposing. This works great if you've got to do a long piece for your prototype. Say I wanted to do a piece like this, I would cut a sort of brace for it. The opposing grain is also really helpful if you want to make sort of a support brace. So I've cut a little strip here, the grain is going this way. Actually, the grain is going this way, and I'm going to apply it to this piece here. So if I were to attach these 2 together, again, I'm getting a slightly stronger piece because I've got this little sort of brace going behind it. Another thing that I like to do a lot with prototyping, especially if I'm trying to make something that's kind of a volumetric form, instead of creating a skin for it, so to speak, I just want to get the shape of the object without having to have a full coverage. So I'm not using the cardboard to make like a surface texture, I'm using the cardboard to figure out the size and the sort of geometry of the object in space. So in order to do that, I usually will create cross sections. So I'm just going to cut a piece here. Now, if I wanted to join these 2 together, I could glue them like this. Cardboard doesn't have a lot of edge, so there's not going to be a lot to grab. This is not going to be a super strong joint. There's a couple things I can do to strengthen it. One of those would be to create a flange. Actually, we can use this piece because this one's already scored. So this piece is a score in it. And if I fold that, now I've got a little flange. Now I can glue this to this piece of material and I've got more surface area to join. So you can see the flange works, but it is still a little bit wobbly. So something I'll do with this is just make a couple of little corner braces. And I do this a couple different ways. So I can just glue a little triangle in there, but again, we've got that open and grain on the cardboard. So if I apply glue to the edge, it's kind of gonna sink into the grain there. Stick that on like that. Another option is so here I've got another way to do a corner brace again with flanges. So I just scored some little tabs on there, and if I apply glue to the flanges, you can see I've got a little support brace in there. So now that will hold. As you can see, very, very rough. This is not meant for beauty. This is just quick and dirty. But if you need to put stuff together, structural, quick, just throw it up there. This is a great way to do it. Another thing that you can do is to create a slot, and basically I'm just carving out a notch in my material. And I want to make sure the notch is about the thickness of the cardboard itself. So it's about like that. And then I'll cut a corresponding notch on my other piece. And I can join these two together, just like that. And you can, again, put some little corner braces in there to sort of hold that in orientation. The only thing to consider really is the depth of the slot for how much you want them to overlap, and just making sure that the width of the slot matches the thickness of your cardboard. So those are the basic techniques for joining cardboard. Most of them apply just as well to foam core. Although foam core has, like we talked about, more surface area on that edge, so you don't necessarily need flanges on all of your joints because you've got that nice flat surface. We can just glue parts together. But I'll show you what that looks like. So I want to make sure that my glue gun is on a low temp setting. So you can see here that I've got a low and a high. I want to make sure it's on low because if not, it can melt the core of the foam core. So I'm going to let that cool off for just a minute. Most of the same techniques will apply for foam core as with cardboard. You can do flanges, you can do edge gluing, you can use reinforcement braces, you can make those little corner brackets. You can also do slots with foam core. This works really nicely. Let's see if we can demonstrate a slot for you. And again, I want to make sure that the slot is about the width of my material. here. So slot just like that. Okay, so this is just edge gluing two pieces together. So with foam core, because it's got those nice straight edges, you'll get a much cleaner prototype, and it has a little bit more dimensionality. So they're a little bit crisper, they're a little bit more rigid, and if you need something that's slightly more polished than just stuff you pulled out of your recycling bin, foam core is a great way to go. You can also save little findings like tubes. I save boxes of every size, different thicknesses of cardboard, all sorts of packing material. That stuff is great and easy to throw together. You can also layer stuff. So like I save all these little cut off strips of foam core when I'm trying to do something sort of dimensional or decorative. You can add layers. You can also use these as spacers. So if I wanted to attach another piece, I could cut a little section and create a spacer between two pieces. Oops. So you can use little scrap pieces like that. There is a point when you have to throw stuff away, but I find uses for little pieces like this all the time. These models here, this is a great example of one where I made use of a ton of scrap. And I also just draw some of my design stuff right onto the surface and translate that into my final project. All right, so now that we have covered sort of the techniques and the design philosophy of why to prototype and how to prototype, I wanted to walk through doing one, actually creating one. So here's something I've had on the back burner for a while, and I thought I would make it today. These are some sort of just back of the napkin sketches of a workbench and a little rolling cart that I want to make. I'm thinking of having a series of little mobile carts underneath of the workbench that I can kind of pull out as I need them. And the first one I think I'll tackle is for my air compressor and air tools. I've actually got two little pancake compressors. So what I'm imagining is just a basic rectangular shape with wheels, a shelf for the larger compressor on the bottom, the smaller compressor on top, and if there's space, a drawer for some accessories. And I'm thinking of having the air tools, the various guns and things hanging on the side, since I don't think there'll be enough space vertically. The reason to prototype is to figure all of this stuff out. So I haven't really done any of the math to figure out if I can fit both of these under my workbench. I know the workbench height is 36 inches that I want to make, so I have to solve for a lot of this stuff. I'm going to do this in miniature scale because it doesn't make a whole lot of sense to build the thing as a foam core prototype at full scale. And I have some material that I think will work well for it. This is 1/8 inch thick foam core. This is a little bit less common. Usually it's about 3/16. This stuff is going to be great because I'm going to build the cart out of 1/2 inch plywood. So this will allow me to do a perfect quarter scale translation of the finished product. I'm going to double check this. It says that it's 1/8 of an inch. Break out my trusty calipers here. 1/8 of an inch. I have to do a couple things before I get started. So as I mentioned, the first thing I always tackle is the sketch. So I'm taking the idea from out there in the ether, translating it down into 2 dimensions, and I can solve for a lot of stuff before I even get to the prototype. So what I'll do is draw out the cart itself, rough idea, and then I'll start adding in dimensions as I figure out what those calculations should be. I also want to measure specifically for my tools, so I've gone ahead and measured the size of the 2 compressors, and I'll have to go in and transfer all of those down to quarter scale and mark the sizes for all of the air tools that I want to house, like all of the guns and stuff that I want to put in the cart. That being said, there's a lot of drawing to do and a lot of measuring to do first. After I do that, I can then take all my dimensions, down to quarter scale, cut it out, and figure out the shape using the foam core. So here's my sketch. While I was doing this, I made a couple of discoveries, as often happens in the design process. What I had in mind is not going to work. So I will need to make some adjustments, and all of them are reason to make a prototype because it will help me to solve some of these problems. So first thing is the 1/8 inch material as an analog for 1/2 inch plywood. When I do the math, the height of the cart at 1/8 scale at quarter scale will be 10 inches, which is, in my opinion, pretty big for a prototype. Does not have to be super detailed. I know how I'm going to use this, and so I don't need to make something that large with that level of detail. So I'm going to go down to 1/8 scale, which means that all of my dimensions will then get smaller, and the height of the cart is only going to be 5 inches. That feels like a comfortable size to be working with to make this prototype. The other thing that I encountered while I was doing this drawing and filling in all the dimensions is that both air compressors are not going to fit stacked in the cart as I had imagined, not if I want them to fit under the height of the workbench. So I could build it out and see how a higher workbench feels. I'm thinking that's probably not going to be the best idea, so I will have to come up with a different configuration. I'm going to build this one first, since it's what I've already drawn out, just to see how it might work out. And I think I will probably make a couple other prototypes, maybe having the compressors side by side. I may also make a 1-to-1 prototype of the actual workbench to see how heights feel in space, how it feels to actually work on top of a surface at that level. So there's a couple different things that I need to solve for, and prototyping will help me figure all of that out. All right, so first things first, I'm going to mark out all of my pieces and cut all the sections. Because I'm doing this at 1/8 scale, I have to remember I'm doing it at 1/8 scale, I have done some of the math already to figure out what sizes I need for all my parts. So grab this ruler, and we're gonna go ahead and assume that edge is straight. And I'm gonna want a 5-inch height. Now I know that I'm going to need several walls, and so I'm going to cut a larger section of material so that they'll all be a uniform height, and I can just cut all of the side walls out of that same overall cart height. So there's my 5 inches. The width of the cart is kind of still TBD actually, but I know that I want the depth to be about 30 inches because that's going to be the depth of the workbench. So that will translate to, let's do some of my math here. 30 at 1/8 scale is 3 3/4. Typically I would do this using a T-square because I'm seeing that not all of my angles are correct. I'm just doing this quick and dirty to show you guys, so it doesn't have to be perfect. But I would usually use a small T-square so that my lines are all perpendicular to the edge. So these are going to be my side walls, and they're 30 inches. It's quite a bit narrower than I was imagining. Again, this is all stuff that as soon as I start making a physical version of it, there are things that I could not have seen by looking at imaginary, not to scale drawings, which means that I'll have a lot of extra space in the back. So maybe some of the tools that I won't have space to store vertically, I can put on the horizontal axis. All right, so I want to make the shelves, which are going to be the same width as these walls. And I find it's quicker to reference existing pieces. Got my second little air compressor here, and it fits in, which means I did all my math correctly. It's hard for me to look at this and show you at the same time, but I'm pretty happy with this. The only problem is the height not fitting under my workbench. So there will be other versions. I'm going to play around with some different configurations. I may also annotate this. I think that I could do some storage for the air guns on the side here, and potentially, because there's so much space in this direction, which I didn't anticipate, potentially there could be shelving along the back for nails and oil and things like that. But as you can see, a little prototype goes a long way in solving for something in physical space before I go to the final materials. Hopefully this has been a little bit of inspiration for you, giving you some ideas about prototyping your design projects. Definitely check out some of the other project videos that the prototypes were for, because there's a whole wealth of knowledge in each of those too. Thanks so much for watching. See you next time.